Basically, what we're going to be talking today here is seeing how SAP is resistant, or which kind of attacks can be done actually to SAP web applications, and what companies can do to prevent that. What I can promise is that we're going to be trying to avoid a very boring and long theoretical talk. We're going to, I think we have like 7 live demos of attacks to SAP web applications, so I hope you enjoy it. A quick introduction to Onapsis. Onapsis is a company that is focused on the security of ERP systems as business critical applications. So we are mainly talking about SAP, but we are also working on other ERP platforms like Siebel, Oracle Business Suite, PeopleSoft, and JD Edwards. We're working with large companies in this sense. I mean, large companies use these systems. And well, we have some software. I invite you to download Bisploits and Onapsis Integrity Analyzer. They are open source tools that you can get from our website. We also have Onapsis X1, that's a commercial tool to do SAP security assessment. Well, we provide different kind of services that you can also find in our website. I don't want to bore you with that. About myself, I'm the CEO at Onapsis. I come from the vulnerability research and penetration testing fields, and then I started digging into the SAP world. So I have been holding trainings and presentations in some conferences. I was also the developer of the first SAP and ERP penetration testing framework. And also I'm the lead author of the SAP Security in-depth publication that I invite you also to download it from our website. It's a free publication with very in-depth technical security aspects of SAP systems. So in these 50 minutes, we are going to be talking about a very quick introduction to the SAP world, how the threats to SAP system has been evolving over the last years, which are the different SAP web application servers, which are the threats to these application servers, and how these attacks can be performed. I would like to know how many of you use SAP in your company. Have, well, pretty much. So I think you will get quite interested in some of the things that we're talking about. For the ones that have not raised their hands, basically, SAP is the largest provider of business management solutions in the world. These are just some of their numbers. There are more than 140,000 SAP implementations around the globe, and over 90,000 customers use SAP around the world. And they use SAP, I mean, we're talking about Fortune 500 companies, governmental entities, military organizations, and they're using these kind of systems not to do like not to support their intranet. They use the system to actually run the most critical business processes. So we are talking about financial planning, invoicing, selling, procurement, managing the payroll. Everything that is the most important information and processes of the company is being run and processed through these systems. So that's why we say that these are the crown jewels of the company, right? So what we're talking about is about the security aspects of standard SAP web applications. So just for you to understand, we are not talking about how you deploy or how you develop your own SAP web applications, and if you are exposed to cross-site scripting or SQL injections or this kind of attacks. That's going to be covered in a future talk. What we're talking about is about threats to the core and standard web application servers. So no matter which application, custom application you are running, you may be susceptible to this kind of issues. So how the threats to SAP systems have been evolving? I think that the main problem I did in DeepSec in 2007, one of my first presentations on SAP security, and back then I even had a harder time challenging what SAP security actually means. The problem with SAP security, from my point of view, is that it has been traditionally regarded as a synonym of segregation of duties controls. So if you have never heard about segregation of duties, it basically means that, okay, make sure that if a user team can create a new vendor, he cannot create purchase orders to that vendor, right? Otherwise, he can make a very easy kind of fraud. So this is mapped into a matrix. Yes, usually Excel sheets are used for this, which is translated in SAP to transaction or authorization objects. And basically, SAP security is checking your user authorizations against an Excel sheet or a matrix. So what we see right now is that many organizations have SAP security in place. So they're spending a lot of money by having a dedicated human resources team and expensive software licenses to serve this purpose. But the main problem that we found, or that we are facing, is that this is also providing a false sense of security, right? Because companies and managers see that they have the people there, they have the software, so they think they're taking care of the security of the SAP systems. And the important thing to highlight is that while these kind of controls are necessary, they are not enough, right? So if you think about an SAP system like a layer stack here on the right, where you have an operating system, a database, what we call the business runtime, and the business logic layer, the segregation of duties control is only applied to this layer. However, what we detect is that this layer, that is usually called NetWeaver or basis layer, is prone to, just as any other piece of software, is prone to security vulnerabilities that, if it gets exploited, will provide an attacker access to perform really serious attacks to the business information. And if you stop to think it for a minute, for someone to exploit the segregation of duties violation, he will first need to have a user account in the system, right? So you will need to have a malicious employee or user that suddenly discovers that he has more authorizations that he should have, and he can perform certain activities that he should not be able to do. However, by exploiting vulnerabilities in the lower layers, the attacker doesn't even need a user account in the system in many cases. Okay? In many default installations of SAP, an attacker, just by knowing the IP address of the system and being able to connect to certain services that are usually or always open, he can end up compromising the system fully, right? So there was something that was definitely not right here. We also see that the threat is rising. This is a chart that we made about the number of SAP security nodes released each year. So in 2005, we were talking about less than 20 security nodes per year. And in 2010, just in 2010, we were almost at 900 SAP security nodes, right? SAP in December released over 500 security nodes. Yeah, so administrators didn't have a very happy Christmas, I guess. And this year, I think that we are already almost around 700 security nodes, but you cannot tell whether it's going to be 750 or it's going to be, I don't know, 2,000 until we get to December and see what happens. So obviously, the larger number of security nodes, the larger number of known vulnerabilities, in some way, the more easy it would be for an attacker to reverse any of these patches and exploit some of these vulnerabilities. This is one of also the main problems in SAP landscape, is that customers do not apply patches very promptly. So I'm often asked what SAP is doing about all these threats and stuff. Well, I have been working with SAP reporting security vulnerabilities since 2006. I think I made the first presentation on SAP security attacks or threats in Black Hat Amsterdam in 2007. And I can really see that they are moving to adapt to this new reality. Back then, it was quite a bit of a surprise for them, but now things are getting better. And you can see that in each new release. The problem is that many customers are still using old releases, and it's not really that easy to upgrade to a new release. So that's why many customers are at risk at this point. So let's get into the core of the subject. And let's start talking about the different SAP Web Application servers. So once you get used to an SAP acronym or a name or a solution, SAP is going to change it, yeah? So don't put too much effort into remembering names or anything. The first SAP Web Application Server released by SAP is the Internet Transaction Server, the ITS. So it was released in 1996, and it's basically a middleware, right? So I'm not sure if it's very clear, but you can see it here. Basically, the user connects to a component called wget, that is like an eSAPI filter running on a web server, like Apache or IIS. This server translates, this filter sends the traffic to another component that is called the agate, and this sends it to the SAP system. So basically, the ITS is translating between HTML pages or HTTP traffic to SAP traffic or pages, right? So it's like a conversion and translation system. So that was the first approach. The second approach was the ICM, or the second solution of web server is the ICM. It's basically the evolution of the ITS component, and now the kernel itself of the SAP system has been enhanced to support HTTP and SMTP protocols. So you don't need anymore a middleware. Yeah. So the first thing that you should tell your customers or think about yourself is that the fact that you don't need a middleware doesn't imply that you just plug it to the internet directly. Yes. Please put a reverse proxy in the middle and place it in a DM seed. Otherwise, you could be in high problems. So for you, we're going to get into deeper into this, but have the idea that what you're accessing when you access the ICM is an ICF service. So it will be like a PHP or an ASP page. It will be the equivalent for that. And finally, you have the Enterprise Portal. Enterprise Portal is the latest web technology from SAP. The idea is that it provides a unique access point to the organizations, SAP, and even non-SAP systems through the web. So here you can see some examples of how it looks like. Technically, this one is running on it's basically a very complex Java application running on a SAP G2EE engine. And it's basically the latest thing that you can find from SAP regarding web access, right? So ITS, ICM, Enterprise Portal, for customers, sometimes it's a bit difficult to choose what to use. And you may find many of them running at the same time. So let's start going into the exploitation of SAP Web Apps. One of the things that we usually find when we talk about SAP Web Apps is like, oh, really, I don't really care because my SAP is only used internally. So that could be true like more than a decade ago. Now it's very common to find SAP systems online. And attackers know how to find them. These are just two silly examples. Are you familiar with Shodan? Yeah. Well, for the ones that know, Shodan is basically a search engine that allows you to search for web servers. You can specify like a string here, and it will search for that string in the server header of web servers indexed online. So here, you cannot see it, but it has almost like 2,000 results. And these are like 2,000 SAP systems connected to the internet, right? Also, you can use some Google Docs to search for SAP systems online, and you will be quite surprised to see the names of the brands that are actually exposing their SAP systems to the internet. So if you think that your SAP system is not public, at least make these quick checks to make sure it's not, at least it's not listed there. So why do I say that this is, the SAP web apps are the attacker's dream? If you start to think it, for an external attacker to compromise a back-end SAP system, he has to reach or to go through several defense layers, right? Like DMCs, IPS, firewalls, whatever. And so it's kind of hard, but he enjoys the privileges of being harder to catch. Yes, he's in a remote country and in a foreign country that it's very difficult to get him to law or whatever. On the other hand, internal attackers have much more power. Usually, SAP systems are not segregated internally, so there are not internal DMCs for SAP servers, so they have access to full ports, full services, and that brings a lot of power to them, but they're more prone to detection. However, if your SAP web apps are not implemented securely, you're basically giving the attacker the best of both worlds, and we're going to see why is that. So let's talk about the attacks. I kind of divided this in a very progressive way, so we're going to first talk quickly about identification. This is very silly or easy. The idea is that just as any web server, SAP also returns the server header in HTTP responses, so you can use this information as an attacker to identify which is the particular SAP web application running on that IP address or that port. So in the ITS, it's not possible because I told you it's like a filter, so you get the IIS or the Apache header, but the ICM and the Java engine, that is the one running the Enterprise Portal, you get quite descriptive header messages, so you can really fingerprint which is the application running on the background. This is how you can, I mean, we're also going to see how you can protect against this or this information disclosure in this kind of like pop-ups. So I will leave that for you as a reference. As an attacker, you can also explore the systems. You can trigger some special requests that will, you can send special requests that will trigger some maybe error conditions or easy things just as analyzing the source code. For instance, in the ITS, if you try to access a non-existent service, like with this kind of syntax, it will show this kind of error or logon screen. And also, if you analyze the source code, you can get the very exact version, right? So this is very useful for an advanced stage on the attack where you, as an attacker, you need to find out which exploit you're going to launch. In the ICM, it's pretty much the same. You can trigger 404 or 403 messages, and the attacker, I mean, there is like a disclosure of information here. You can see the host name. You can see the subsystem ID that is very useful for some further attacks. This will be like the name of the system, and also the system number. In Portal, it's also very easy. Just right-click, view source, and you have the exact version of the Portal runtime over there in some HTML comments. This is how you protect against this. But let's start really getting into something more serious and more interesting. And we're going to start talking about attacks to the ICM first, right? So I told you that when you access the ICM, you're going to be accessing an ICF service, right? And by default, there are over 1,500 standard ICF services in a typical SAP ERP installation. So this would be equivalent to 1,500 ASP or PHP pages that you run when you install the system. So each of these one will receive parameters and will perform certain activities on that parameters, right? So there are injection points. When the ICM receives a request for one of these services, the following procedure will take place. First of all, the system will check if it's public or private, right? If it's public, it will just give you the content or do what it needs to do. And if it's not, if it's a private service, it will check for certain things that really doesn't do many good to go into detail. But basically, it will trigger an authentication mechanism, right? So if the user authenticates successfully, then it will check if the user has authorization to run that specific service, and if he has, the service code is executed. So to be fair, most of the services require authentication, yes, but we will see why this cannot be so much of a barrier for an attacker. Anyway, for instance, here we have a public service that is installed by default. It's called the the info service. So this is basically the URL that where this is published. So it will be like ip.port/sap/public/info. Without authentication, this service will give you an XML or a SOAP actually response where you can see the system ID, you can see where the database host is stored, you can see which database engine it's using, the SAP release, the operating system that is being used, internal IP addresses. So very useful information from an attacker to also to an advanced stage. But let's really get a bit more serious. So I told you that most services require authentication, right? And I told you that also once the user authenticates, the system will check if he has authorizations to run that service. The problem number one that we found is that actually the authorization check usually does not apply because services are by default not assigned to an authorization group, let's call it that way. So the default behavior is that, okay, do not check for authorization. So that means that the attacker will only need a user account in the system. Yes, it doesn't matter that much how many privileges that user have, and he will be able to access the service. Then he will obviously be subject to code level authorization checks, but at least he can access the system with any, the service, sorry, with any user. And the second, while it can sound a bit silly, you will be surprised on, I mean, we are regularly doing SAP pen tests for very large companies, and you will be quite surprised to see how common, I think actually in all the pen tests that we did, we found at least one, systems are configured with default users and passwords. So these are the default users like SAP Start, Dedic, Early Watch, SAP CPIC, and TMS IDM, and they have publicly known default passwords. So the attacker has a lot of chances to find one of these configured. And as an additional note, the attacker can also control which mandant or client is something very SAP specific. But I mean, what you want to get out of this is that, okay, an attacker needs authentication, but there will be no authorization check, and it's highly probable that he can find a user, a default user to trigger that service. So what this turns out to be is that the attacker has fair chances of accessing really sensitive business functionality through the ICM services. And we're going to see some demos of that. In particular, we're going to talk about one service that is called SOAP, RFC. So the RFC is a special proprietary SAP protocol that is used to call function models, yes, to call function models in remote SAP servers. So this is what we actually presented, our first presentation in Black Hat, and here actually at DeepSec, we presented a lot of threats to this interface and a lot of ways into an attacker can exploit weaknesses in this interface. But from an external point of view, this protocol or the interface implemented this protocol is not usually accessible from the internet, right? However, there is an ICF service that can be used to perform RFC calls. So if this service is enabled, that is also usually is enabled, an attacker can perform RFC calls to the web application server just as he was sitting in the local network. That's why I told you about this paradigm of like being external but having like the internal power, right, from an attacker point of view. I know this looks a bit like ugly, right? So let's go a little bit into detail before the demo. This is a user on an SAP server with an overly simplified version of an SAP server where you have the web application server interface and the SAP RFC interface and the operating system, right? So from the internal network, the user gets access through HTTP to the web server and through RFC to the RFC interface. However, from the internet, the RFC connection is stopped at the firewall, right? It only allows web connections. However, what the attacker would do is trigger this special SOAP RFC service, that this is an ICF service, to call RFC function modules. And we're going to see what that actually can mean. So I'm going to make the first demo. First of all. So actually the first demo is sorry about that. It would be like a very simple case of a sabotage attack, right? So this is SAP Web. This is like the client that is used to connect to an SAP system. So I'm going to be connected to the system, right? I'm going to be, I mean, this would be the end user using the system to create vendors, whatever. So we're going to use an exploit. I want you to actually, I will make this, sorry. Well, I wanted to do exactly the opposite. Okay, I'm going to do it now. So what I'm going to be doing here, I'm going to show you the exploit. I don't want to do like black magic. Basically, well, this really doesn't matter, but basically what it's doing is, this is the key part, right? So it's making a SOAP call. I mean, I have to do it with a Python script because it's only post. I cannot do it with a get. Otherwise, I will do it with the browser. But basically, this is going to be calling for a function module, an RFC function module through a SOAP call through the web interface, right? And we're going to see what that means. So if you see that we have the screen here, the user is logged in, and after we run this, the Windows is closed, right? So basically what the attacker is doing is logging off all the users connected to the SAP system through the web application, right? So you can imagine that, companies, most of their employees are just, their everyday work is running the SAP transactions, right? So an attacker could be like, you could put this in a loop, right? And continuously log off every user in the company. So obviously that will mean some costs for the organization because employees will probably need to go home. So that's a very simple sabotage attack. The second one is actually also a bit silly, is about spamming through the same way, right? So I'm going to connect again to the system. So, okay, so I'm connected here. And I'm going to use another exploit or another subcall that is called spam. That is basically the same, it's like another payload, right? It's the same attack vector like calling an RFC function model remotely. And you see that what the user will get in his screen is spam messages from the attacker remotely, right? This is the SAP Web screen. But I know, this is just funny things. Oh, I forgot to do something. So let's get more serious here. Let's use so we'll do the demo number 3 from the web to the shell. Sorry. No. So I'm going to launch this exploit. Oh, sorry. So I'm pretending to be the attacker here. So this is, oh, sorry, you cannot see that. So this is my username. This is my IP address, right? Oh, well, the attack was triggered. I couldn't stop it on time. Let me close it. So this is my IP address, right? So I will trigger the exploit, and what the attacker gets is basically, I don't know if you can see that. It's a next term, right, in the 3.4, yes. So this is actually the remote SAP system. Yeah? So he's getting a remote shell through he's making a SOAP request and getting a next term shell. Yeah, I'm going to explain that in a minute. But obviously, if the attacker, if this is not comfortable enough, he can also use like something like Nautilus and get a graphical file browser to go through the SAP system remotely. So he can get into, I don't know, file system, user, SAP, and he has full access to the system, let's say the system profiles, anything that is on the remote SAP server. So that's actually a full compromise of the SAP system through a weak ICF service.
What is the SOAP request for that one?
Sorry?
What is the SOAP request for that one?
I'm going to explain it now. Yeah, I know that this can sound a bit strange, right? So what actually happened over there? The attacker is doing, I told you we could execute RFC function models. So what we are doing, then I can show you the code. The attacker is basically sending a SOAP request to execute a function model that is called thgrep, right? So this function model, the legitimate use for that is to search for strings in files. And what's really important is that this can be executed by the early watch user, that is one of the standard users that are thought to be like, I don't care about early watch, it doesn't have many privileges, right? So a friend of mine from the Netherlands discovered a command injection vulnerability in the RFC module. So actually what we're doing is, okay, from the web, we are triggering a call to an RFC function model that we are injecting operating system commands to get to the operating system layer. And just for the demo purposes, where what we're executing is exporting the display and getting an extern back, right? So that's why you could get the extern. But obviously, that will require an outbound connection. It's not that difficult to find like weak firewalls, but that's not really necessary, right? That's just for the demo effect. But once the attacker is running operating system commands, at that point with that kind of privileges, he's already the full owner of the system and he can access any kind of business information, right? So that's what happened. So anyway, when we do this kind of tests, we usually, if we go to a manager and we show them that we could get a command shell with a reverse connection with exporting display, they will look at us and say, okay, yeah, I have to play golf tomorrow and I don't care really much about what you're talking about. So what we try to do always is to show what this actually could mean to the business, right? So what I'm going to do now is to use other exploits that will actually mean something for the business. Let me close this. Okay, so what I'm doing, I'm going to show it here. Again, that's another RFC call. And the RFC function model that we're using is RFC read table. So it's basically a function model that allows people to read SAP tables, right? So I'm going to call this. And what you will see is that it returns this XML output. So I'm going to send it to a file for us to be able to see it in a better way, right? Okay. So the attacker through the web is executing a function module that allows him to read tables. What he's reading in this case, he's reading the tables with the credit card transactions of the SAP system. So here you have like the MasterCard, the credit card number, and the amount of the operation. You have here the names of the guys that were running this transaction. So this obviously could mean something for the PCI guys, right, that are over there. So this is one example. You can read tables from credit card transactions. Another two examples are, I'm going to execute another that is basically accessing another table. So we're going to refresh that. And in this case, what the attacker can get, for instance, is all the human resources payroll information. So everything that you see here, this is like the personal number, the name of the employee, the birth date, in which state he lives, and I don't remember clearly, but one of the others were like sex, religion, so this one here. These bytes also reflect religion things and sex and other things. So let's make a quick example. Let's say, okay, Julia White. So let's copy the personal number of Julia White. We'll execute the last exploit regarding this, because we have to look it up in another table. And what the attacker will get is, okay, this is how much Julia White earns a year, right? She earns 56,000 euros a year. So obviously this is quite an interesting disclosure of information. What's important to also mention is that, we are using function modules that are used to retrieve data, right? This is espionage only. But the attacker can also use function modules to modify the data. So if he's a friend of Julia White, he can maybe add a 0 here, and Julia will have a great holidays in Cancun or whatever. So this is completely possible to be done over the internet. So let's get back to this. Oh, sorry, I had to do some some switch of the VMwares. Any questions so far? I can take one question, maybe in the meanwhile.
All these bugs that you find in the software services that have been found with line testing of the web service itself or reversing the server side?
Well, actually, I wouldn't say it's a bug. I would say it's like an abuse of functionality because
I mean, all these function names and codes are documented something?
not all of no. The ones, yeah, no. Yeah. Okay. So let's go back to it. Yeah, actually, well, these RFC function models that we have executed, they are over 25,000 RFC function models in a standard SAP installation. So you can definitely find a lot of things to do. So again, this is how you protect against this. Well, actually, the one that we use to execute operating system commands has been patched, and there are some ways into how you can protect against some of these threats. The most important thing here is to disable the SOAP RFC service to just close it at there. Yeah, stop it there. Well. So finally, I want to talk about something I actually discovered regarding the security of enterprise portals that I think you will find quite interesting. So I told you that Enterprise Portal was the latest web technology, right, from SAP. So Enterprise Portal supports different authentication mechanisms, such as typical user and password, client certificates, logon tickets, that's SAP proprietary, Kerberos, and many different authentication models. Actually, authentication is handled by the Java engine, right? Not by the Enterprise Portal. So what we're talking about actually is really affecting the Java engine. So it doesn't matter which kind of application you're running on top, if it's Portal, PI, Solman, whatever. The thing is that many organizations already have like web access management or enterprise access management solutions in place, and they want to integrate that with enterprise portals. So maybe they want to integrate them because they want to do single sign-on, or maybe they want to increase the security of the solutions by, for instance, adding like a two-factor authentication and providing like access through tokens, biometrics, or things like that. So these are some examples of solutions that integrate with SAP enterprise portals that allows you to perform this kind of single sign-on or increased authentication procedure. So in order to do this integration, in order for you to authenticate, let's say, with an RSA token, and that token is being validated with the portal and grants you access to the portal, SAP uses something called header variables login module. That it works like this. Yeah, it's just for you to have as a reference, but we're going to see it in graphically. Oh, sorry, first of all, let me check that. Well, I can check it later. Okay, so how this works. We have the user that's going through a firewall. We have the authentication proxy. These two would be like the enterprise access management or web access management solution, and you have the enterprise portal, right? So the user sends the credentials to the authentication proxy. This could be user and password, or it could be like the token, it could be the biometric information, anything. So the proxy will check in its own directory whether this is valid or not. So if it's valid, it will say okay, and the authentication proxy will connect to the enterprise portal with this header variables login module and tell him, okay, authenticate this user. Enterprise portal will say okay, and the user will get his cookie that he will use to keep on connecting to the portal. What's the problem here? What if the attacker can connect directly to the portal and like kind of impersonate the authentication proxy? So let's see how this actually looks like. I think that some of you may already imagine what we are going to do. Sorry, no, 3.6. Okay. So the first thing I'm going to do is to access the enterprise portal system. This is a login screen for enterprise portal. I'm going to show you that this is running. I'm going to log in as administrator. Oh, I have to change. Okay, so the administrator is happily using the system and everything works right. So let's close this. Let's open a new one. And let's also open our friend Verb. Okay, so let's say now that this is an attacker that faces, he has discovered the SAP Enterprise Portal online, and he accesses the URL, and he's faced with this authentication screen, right? So he will try administrator, and he will do like a long shot, okay, admin, okay, this doesn't work. So company name, okay, this doesn't work. So he will try, instead of doing this, he will try a different thing. He will use Verb. Is everyone familiar with Verb? Right? Okay, great. I can skip that. So we will set Verb, I think it's already set for intercept, yeah. So the attacker will click, no user, no password, right? This is a very, very complex attack, so pay attention. So the user clicks on logon, right? And the only thing that he will have to do is add a special header, in this case called remote user, with the username he would like to be. So he sets this forward.
No way.
Thank you. Yeah. So actually, obviously, when I was starting when I discovered this, I was really surprised and kind of excited, I had to admit. But it was even worse, actually. Then I also, I started searching for it online to see if there was anyone else who had done it or anything else. And I actually found that this was somehow documented in some SAP formal documentation since 2006. Okay, so we're talking about 5 years ago.
So it's a feature, not a bug.
It's a feature, yeah, it's a design problem, let's say it that way. So it's important to read the documentation, right? Yeah, the main problem here is that, how you can actually, you have here the countermeasure. The main problem or the main way to solve this is to avoid this guy connecting directly to the portal. Okay, so what he's doing actually is impersonating the authentication proxy. So you have to make all your users and attackers go through the firewall and speak to the authentication proxy, not directly to the portal. That's the way into how you can protect this. And it's actually, if you think about this, we're talking about high-profile organizations who have thought about increasing the security and the authentication to the systems, right? And if they're failing to do that properly, they're actually making it much worse. They're just making it anonymous, right? So it's really important to actually, we did an assessment of a customer that they implemented all this, but as users in the first place, they not connected through a firewall, they changed user URLs to connect to authentication proxy, but the firewall was still open to access the enterprise portal directly. So the attacker can still go through that hole. That's the key point. Yeah.
The authentication proxy is not, I don't know SAP, but it's not even working as a reverse proxy in front of the application server.
Yeah.
So in that case, if you have a reverse proxy in front of Tomcat, for example, Tomcat is listening on AJP, so you couldn't access like the application server.
Exactly. That's the point. That's how you secure that. You have to force everyone to go through that channel.
So this is, okay, so no one is doing that.
Exactly, yeah.
Okay.
Well, I wouldn't say no one. I would say that we found cases where people were not doing that, yeah. Okay, finally, last thing to talk about, some post-exploitation things. I mean, once the attacker has access to Enterprise Portal, as administrator, he can do everything he wants. He can access business information, anything. And he may try also to install a backdoor to secure future access to the system, right? So, well, this is some background information, but just to make the long story short, as you have the ASP shell, the PHP shell, GSP shell, we realized that there was not a Sap Portal shell, right? So basically, what we did was a par shell. Par is the name of the portal application. Stands for, it's like similar to a WAR file. Let's see how that looks like. So once the attacker has full access, he can go to this convenient tool that's called Portal Archive, Deploy, and Remover. Browse his files, upload the portal shell app, upload, and then he has this URL for the future access, and he can do anything he wants, right? So this would be like a partial for enterprise portals. Okay, further attacks. Yeah, it's really impossible to talk everything that we can about attacks to web applications. I just wanted to highlight two more things. The first one is the verb temperance attacks. I don't know if you're familiar with the presentation that was done in Black Hat this year in US by a Russian security researcher called Alexander Polyakov. He discovered that some of the Java web applications were prone to verb tampering attacks. So let's say, to make it easier, if you don't know the term, it's like they were restricting the get and post methods, but you could still use a head method to access that. And it's really a very important vulnerability because it will allow anyone to create an administrator user anonymously, so really critical. Also, something that you can check on our website is something we call invoker servlet detour attacks that also will allow attackers to bypass authentication and authorization checks and access to sensitive functionality. You can see that in the paper. And well, many more things that unfortunately, some things are waiting for patches, and some things we cannot just make it fit into 1 hour talk. So conclusions. Actually, there is really a lot of SAP systems connected online. So if someone tells you that his SAP system is all internal, make a double check on that. Obviously, this increases a lot of the risk because the universe of possible attackers is widened and the chances to catch them quite reduced. As I told you, there are many different kind of web technologies from SAP, so it's really important, and they're like completely different one to each other. The security models or the authentication model, everything is different. So you have to know really well the specific component that you're trying to secure. As I told you, SAP is getting better in this. There are new security guides. Since last year, they started releasing regular security patch days. So that's kind of cool. And there are some recommendations that organizations should follow. As I told you, there are things that are documented since 2006, and people are still not following that. Don't connect the SAP systems directly to the internet. At least use a reverse proxy or a web application firewall. And if I want you to take one thing out of the talk is that remember that if someone exploits a vulnerability in an SAP web component, a remote attacker may be able to get full control of the SAP system and access all the business information in that system. Not just technical data or pop up a shell out of it, but get access to credit card data, to human resources data, to financial results, everything that's stored in the system. So I really think that this is the only way to manage this kind of threats. What I think when we started with all this SAP research, there was like some people that were not very keen on that, and they thought that it was better to keep it quiet. But ultimately, I think that it was not a very good position for actually companies or users because they didn't know the threats that they were facing. So what I just want to make them know the threats that they're facing. If then business decides that it's a risk that they can take that's perfectly fine with me, but it's important for them to be aware of the threats.